Hey friends! Okay, so today is lesson 4 in our rational expressions and equations unit. For 30-2, we are going to tackle multiplying and dividing rational expressions, okay? So we've now talked about non-permissible values. We've talked about simplifying, factoring things first, and then trying to simplify. This is not a super large stretch after that conversation. It's just kind of putting a bunch of things together. Except we need to make sure that we are thinking about how to multiply just regular old fractions or divide regular old fractions, okay? So let's see, I'm just going to hide my head for 1 sec. Let's see if we remember how to multiply and divide fractions without using our calculator. So we're going to take a look at the following. 3 over 7 times 2 over 9. Now, when we do fractions that we multiply together, all we have to do is multiply the tops, multiply the numerators, and then multiply the bottoms or denominators together, and then reduce if we can. Sometimes we can reduce ahead of the game. So what I'm actually going to do just to show that to you here, like I could just go straight up, 3 times 2 is 6, 7 times 9 is 63, and call this 6 over 63, and then reduce after that. But what I want to do is just kind of have this conversation around what does it look like if we were factoring? And so instead, what I want to do is I want to call the 9 3 times 3 for a second. Now, why would I do that? Well, I would do that because just trying to get my ink turned on here right quick. There we go. I would do that because now I can see this 3 and this 3 could divide each other out. 3 divided by 3 is a 1. Okay, so then I'm looking at, hey, now I just have a 2 on the top, and on the bottom, I have a 21. Okay, now if you had said, no, I don't want to do that, I want to go 6 over 63, you would then be looking at this and saying, okay, how can I reduce that? Oh, both of these are divisible by 3, so then I divide that by 3, divide that by 3, and I'd still get 2 over 21. Okay, this is a little easier if I factor first, because then I can divide out my common factors right away. Okay. Awesome. Let's try the next one. 1 over 3 divided by 7 over 6. Now, the first thing I want you to notice there is we're dividing. When I divide, I change it to multiplication, and then I take the reciprocal of the second fraction. Okay, so I flip it and then change it to multiplication. So I'm going to rewrite this as 1 over 3 times 6 over 7. Okay, now I'm going to do the same thing. I'm going to factor that 6. I'm going to call that 3 by 2. And then I can see, hey, these 3's right here will divide each other out because I have 1 on the top and 1 on the bottom. And that will leave me with just 2 over 7. Okay, so that's what we're going to do today. It's just that it's going to be with polynomials on the top and on the bottom that I'd have to factor first, okay? But the same principle still applies. If I have an x plus 5 on the top and an x plus 5 on the bottom after I'm done factoring, then those guys divide each other out, okay? All right, so I'll clear that ink and we'll try this. Multiply and divide the following, state all restrictions, okay? Just hide myself 1 second there in case you don't see the full question. Okay, so I do have a variable on the bottom of a fraction now, so I want to think about restrictions. X can't be 0. So I'll start there. And then I want to think, okay, well, maybe I want to just multiply these together first. Doesn't matter. Maybe I want to see, hey, the x squared and the x, one of those x's will divide out. Great. If you want to do that right away, awesome. Okay, I'm going to take it kind of in baby steps here. I'm just going to multiply the tops, multiply the bottoms. That's going to give me 15x squared over 14x. Okay, 15x squared over 14x. Now, 15 over 4, I can't reduce that at all. But this x squared over x, when dividing powers of the same base, I subtract the exponents, right? We're back kind of into a simplifying conversation that we've already had. Or I could look at it as xx over x, right? Either way, one of those x's is going to divide out, and my final answer will be 15x over 14. Okay, 15x over 14. Okay, easy peasy. Okay, let's try the next one. 10 over 3x times 6x over 5x cubed. 10 over 3x times 6x over 5x cubed. Now again, let's think about restrictions. X can't be 0. Now, what I'm going to do here is I'm going to actually take a look at my numbers and just start reducing things right away, okay? I'm going to say, hey, watch what I do very carefully, okay? I'm going to say 6 divided by 3 is the same as saying 2 over 1, okay? I'm also going to say, I'm just going to switch colors so that you don't get them mixed up. 10 divided by 5 is 2 over 1, okay? And so then I can just go, hey, I've got 2 times 2x over x times x cubed. So something like this, okay? Then I might want to say, hey, my x divided by x, that'll divide each other out. And so I'm just left with 4 on the top, 2 times 2, and x cubed on the bottom, okay, where x can't be 0. So 4 over x cubed would be my final answer there. Okay? See, this isn't bad. We got this. Okay. Now, again, every question I give you, we're just going to kind of add a little layer. Now we've got a little bit of factoring that we want to think about. We want to take a look at that top left numerator there. And we want to think, okay, I can take out, what's the greatest common factor there? I can take out a 2x. If I take out a 2x, I'd be left with x minus 6. Okay. Then I can take a look at this. Next step would be I want to talk about restrictions. So if I want to talk about restrictions, I'm going to say, hey, x can't be 0 here, and x can't be 6 here, okay? And then I want to think, okay, now is there a way I can simplify this? Well, the x minus 6 divides the x minus 6. That'll become a 1. X divides x. And then 5 over 15 would reduce to 1 over 3. Okay, so actually now my final answer is just right there. Everything else got divided out. My final answer will be 2x over 3. 2x over 3. Okay, now it's probably a great conversation to have here just to say, hey, look, there's no variable on the bottom here anymore. That doesn't mean your non-permissible values aren't there anymore. You still have to think about the non-permissible values because you have to remember the original question was this guy up here, and in there, I can't plug in 0 and I can't plug in 6. Okay, so just because it simplifies to something prettier doesn't mean the non-permissible values go away. Okay. Yay for us. Okay. Let's try the next one. Again, now I'm dividing. So I know I'm going to want to change this to multiplication and flip the second fraction. I also have some factoring to do. The 3x squared minus 9x can be factored, and the 6x minus 18 can be factored. So let's deal with the factoring first before we start looking at doing any math, before we switch it to multiplication. Let's just deal with the factoring. Okay, so in this bottom left-hand corner, I can take out a 3x, and I'd be left with an x minus 3. Here, I can take out a 6 and be left with an x minus 3. Okay, so that would be my factored form. Now, I want to think about non-permissible values. For here, x can't be 0. For here, x can't be 3. That's repeated here. Okay, I also actually want to think about the top of this guy. Because he's about to be flipped, so he'll actually appear on the bottom as well. But there's no variable there, so it doesn't create any additional NPVs. So x can't be 0 and x can't be 3. Okay. Now I'm going to rewrite as a multiplication statement. So I've changed my division to multiplication and I flipped the second fraction. Okay. Now I can see, okay, well, my x minus 3s will divide out to be a 1, and then my 6 divided by 3 is 2 over 1. Okay, careful, this 5 does not divide out with this 5, right? You see that? That would be a kitten killing moment if we did that. We don't want to do that because the 5 isn't a 5 by itself, right? It is connected to the x minus 5. So the only way I could get rid of it is if I saw another x minus 5 down there. So I'm going to have 2 times x minus 5 on the top. And then on the bottom, what do I have left here? Looks like I have 5x on the bottom. Okay, so 2 times x minus 5 on the top, and then 5x on the bottom. Okay, so in this next one, I've got x minus 1 over x plus 4 divided by 3x minus 3 over x squared minus 16. Again, I want to start by factoring, okay? So on the top right, I could take out a 3, and that'd be 3 times x minus 1. On the bottom right, I want to see a difference of squares there, so that'll be x plus 4 and x minus 4. Okay, so we've got our factored form. Now I want to talk about NPVs. Now I alluded to this in the last example. Now it actually does matter about where I look for my NPVs. And essentially I want to look at all of this highlighted region, okay? NPVs exist, or restrictions occur, whenever the bottom of a fraction equals 0. Well, in the second fraction, both the top and the bottom are going to become the bottom at some point, because I'm about to write this as a multiplication statement and flip that second fraction, right? So I have to actually look for NPVs on both the top and the bottom. So I see x can't equal -4, x can't equal -4 again, x can't equal +4, and x can't equal +1. So my non-permissible values, or my restrictions for this guy, would be x can't equal 1 and plus or minus 4. Okay. Now I'm going to rewrite it as multiplication. And then I'm ready to see what sort of things I can simplify out while I do the multiplication. So x plus 4s will divide out, and the x minus 1s will divide out. And so I'm left with x minus 4 over 3. Okay? All right, let's take a look at the next one. Now, at first glance, this can look a little scary. We've got lots going on, okay? What I want you to look at is, this is just like 6 little factoring questions in one, okay? We can totally handle 6 little factoring questions in one. Not a big deal, okay? So let's do it. Let's start over here. I can take out a 9x, and I'd be left with x plus 4. On the bottom, I have a difference of squares, so that'd be x plus 4, x minus 4. In the middle top, I can take out a 2 and be left with 3x plus 2. On the bottom, I can take out a 6 and be left with x minus 5. I assume you've done all this. You paused me, right, and did this yourself. On the very right side top, I can take out a 2x and be left with a 3x plus 2. And then on the very bottom right, I can take out a 3 and be left with x minus 4. Okay. All right. So that is my factored form. Now, I want to think about non-permissive values. Again, I'm looking at anything that will appear on the bottom at some point. So my non-permissible values are going to look like this, because this fraction is going to get flipped. So I have to think about both the bottom and the top for that guy. So x can't be plus or minus 4 from these guys. X can't be 5, and x can't be -2 over 3 for this top guy. Again, if you don't see that in your head, you're not going to try it in your head. You're going to go 3x plus 2 equals 0, and you're going to isolate for x. Okay. All right, awesome. Then I'm going to rewrite as a multiplication statement all the way. So I changed that guy to multiplication and flipped the second fraction. Okay, so now I'm ready to do some dividing out. So let's take a look at x plus 4s will divide out, x minus 4s will divide out, 3x plus 2s will divide out, x and x will divide out. Oh, look at that. Sorry, I missed that. X was all a factor all by itself there. What a great conversation to have. I also need 0 there, right? X can't be 0. Super, super important, okay? Make sure you've added that x can't be 0 to that one, okay? Okay, what else is going on here? My 2 divided by 2 would be gone. And so I'm left with what here? I've got 3 over 6 would reduce to 1 over 2. I think that's everything. So it looks like on the bottom, I've got a 2 times x minus 5. Everything else is divided out. And on the top, I've got a 9. So final answer would be 9 over 2 times x minus 5. Okay, 9 over 2 times x minus 5. And just because I erased my ink there, I'm going to quickly just add in, don't forget the 0 with all my non-permissible values. Okay, 0 with all my non-permissible values would be lovely. Okay, so that question obviously was a little longer, friends, right? But what I want you to notice is a couple of things. Number one, it wasn't anything you didn't know in the first place. You knew how to factor each one of those. You knew how to divide fractions. Okay, it was just a little longer. The other thing though is these questions are designed that they clean up decently well, right? This is kind of a nice, cute little answer after all that big mess. If you do a question and you find it doesn't clean up at all, you might just want to go back and check your work. Make sure you didn't make a mistake along the way. Okay. All right. Awesome possum. Let's take a look at this. I'm going to hide my head so you can read the question here. The base of a triangle is given by 4x minus 16 over x. And the height of the triangle is x over x squared minus 16. The simplified form of the area of the triangle can be written in the form a over bx plus c, and we want to determine the values of a, b, and c. Okay, all right. So we know that area of a triangle is base times height over 2. I'm just going to call that 1/2 base times height, just so I have the 1/2 in the front. Okay, I know the base, I know the height. I'm going to plug those things in, and they're all being multiplied by each other. Okay, so now this is right back to like what I just asked you in the last example. It's just a bunch of things happening. I gotta factor what I can, and then I'm ready to simplify. So the 4x minus 16 right here, I can take out a 4, and that would leave me with x minus 4. On the bottom here, this x squared minus 16, that's a difference of squares. So that's going to give me plus and minus, or x plus 4 and x minus 4. Okay. Now, let's talk about restrictions in a context, okay? Because you may look at this and you may say, oh, okay, x can't be 0 and x can't be plus or minus 4, okay? And in some respects, I might agree with you until we think about just the fact that if I'm talking about actual lengths here, the fact that I have an x minus 4 here, that actually tells me that x has to be greater than 4. And I want you to think about why for a second. Let's say x was 3. Okay, if x was 3, I would end up with a negative number here. And so I'd end up with a negative number times a positive number. That would actually give me a negative number overall. And I can't have the base of a triangle be a negative number. Okay, so in that sense, it's not just what x can't be. I have to just kind of think a little deeper about the context of the question. When we're dealing with real life things, you know, lengths of shapes or something like that, areas of shapes, you can't have a negative answer. Okay, so I want to make sure that I don't have a negative answer, and that's why I'm saying x has to be greater than 4. Okay, all right, awesome. Cool. So let's then keep going here. My x minus 4s will divide out and my x's will divide out, and 4 divided by 2. Let me write that down for you here. My x minus 4s divide out, my x's divide out, and my 4 over 2 will be 2 over 1. So it looks like I'm down to 2 over x plus 4. 2 over x plus 4, which would be the area of the triangle. Okay. So I'm gonna erase this and put that there for you. Okay, now it didn't actually ask me what the area of the triangle is. It asked me to state the values of A, B, and C. So what I need to think about here is, okay, A is 2, B is the number in front of X, which would be a 1, right? And then C is 4. So I want to make sure that I actually conclude by answering the question I was asked. A is 2, B is 1, C is 4. Okay? All right, we totally got this. Let us summarize, okay? So, in summary, if we have a binomial, try factoring first, then try simplifying before multiplying and dividing. You don't want to start the multiplication and division right away until everything is factored. Remember, in previous units, I've always said, no matter what the question in rationals, sorry, in previous lessons, I mean, I've always said, no matter what the question is, your first 3 steps are always the same. Number 1, factor. Number 2, state your restrictions or your non-permissible values. Then number 3, you can start simplifying or actually doing the math you're supposed to do. When multiplying fractions, multiply numerator with the numerator and denominator with the denominator. When dividing fractions, you want to take the reciprocal of the second fraction and then multiply. Okay. Awesome. Always find the restrictions after factoring, but before simplifying, right? Just that's important because even if they divide out, it doesn't mean those restrictions go away. And then when dividing, we must look for restrictions in more places because we are going to take the reciprocal of the second fraction. So just be conscious that any fraction that you're dividing by, that fraction, you have to think about restrictions from both the top and the bottom. Okay? All right, friends, that is it for me for multiplication and division. And now you can go and try a few things yourself. Make sure you're feeling comfortable about this. Remember, make sure you do some work on your own. It's always easy to watch somebody else do something. It's a little harder when you're the one picking up the pencil and trying it yourself. So please give yourself the time to do that. Ask me questions where you're lost. I'd love to help. And yeah, next video, we will talk about adding and subtracting rational expressions, okay? But until then, thanks for watching. Thanks for letting me take this little journey with you, this mathematical journey. Thanks also for letting your friends know about these videos. I really do appreciate that. And I appreciate you subscribing to my channel. So thanks for that as well. You guys got this. Take care, everyone.